Hi guys. Okay, so we're going to talk about exponential functions today. So remember, any function of the form f of x equals a number raised to the x, like y equals 2 to the x, y equals 4 to the x, y equals 1/2 to the x, y equals e to the x, are called exponential functions. Now, we're going to go to our calculator and we're going to graph them. Ready? Okay, so we want to graph 2 raised to the x. We want to graph 4 raised to the x. We want to graph the fraction 1/2. Notice how I'm putting it in parentheses so that both the top and the bottom are being raised to the exponent of x. And then we want to put in the function e to the x. Now notice, I'm just going to move these names over here. Notice all these graphs cross through the same point here at 0, 1. All of them have a horizontal asymptote at the x-axis, so the line y equals 0. Most of them are increasing, and this one is decreasing because what's another way to write 1/2 to the x? That would be if I tabbed up and I did 2 raised to the negative x, we would have the same function. So these two functions are the same. So when that exponent is negative, it's decreasing. Okay, so when we graph those, you should have noticed that the domain was all the reals. You can use any x value. The graph goes forever left and forever right. However, the range, because we have that horizontal asymptote at y equals 0, our range is y greater than 0. And every point on an exponential graph that has not been shifted up or down, every graph has to go through the point 0, 1. And we said just a moment ago that the asymptote is the horizontal line, y equals 0. These are the basics of every exponential function, okay? One more thing that I want to review is from pre-calc. Remember, we looked at the limit as x heads to infinity of the quantity 1 plus 1 over x all raised to the x. We did this last year by graphing this function, and we looked as the graph went off to the right. As the x's got huge, what happened to the level? And we even looked in the table. These y values, 2.7176, 2.7178, 2.7179, 2.718, 2.718. They seem to level off to 2.718. And this was our new number, e. It's an irrational number, non-terminating, non-repeating. Okay? And then we went and we graphed y equals 2, that's the red line here, and you can see that that is a horizontal asymptote. That means that the limit as x heads to infinity of this 1 plus 1 over x raised to the x is e. Okay, hopefully you remember that from pre-calc. And now, remember, that e is what we call the natural exponential function because it's related to the natural log and it shows up in nature. The next thing we're going to do is we're going to go to our calculator and we're going to graph the function y equals e to the x, and then we're going to see if we can graph the derivative and guess what the derivative is. So in f1 of x, we're going to graph e raised to the x. And there's our graph, should look familiar. Now we're going to go to our template key and do d box of box so that we have d dx of, and now you can either type in e to the x or you can type in f1 of x, that's totally up to you, and hit enter. Wait a minute, I only see one graph. Look at that. The graph of e to the x and its derivative are the same function. Okay, so we just saw amazingly that the derivative of e to the x is just e to the x, or the derivative with respect to x of e to the anything is e to the anything times the derivative of the anything with respect to x. Remember, that second option Just a reminder to use the chain rule. Okay, it's just a reminder to use the chain rule. So here we go, let's try one. We're going to find dy dx, and we have y equals e to the negative 3x squared plus 1. So the derivative of y is dy dx. The derivative of e to the anything is e to that anything times the derivative of negative 3x squared plus 1 is negative 6x. Now I put that in front so that it doesn't accidentally look like it's part of my exponent. I tend to write my e part at the end so that my negative 6x doesn't get messed up in the exponent, okay? Now, let's look at this one. Y equals sine of e to the x. So the derivative of y is dy dx. The derivative of sine is the cosine, keep the angle, times, don't forget we have to do the chain rule. What's the derivative of the angle e to the x? It's e to the x. And this time I put it up front because I didn't want it to look like it's part of the angle for my trig function. You're going to write it where you feel comfortable, okay? Now, this one, y equals x squared times e to the x minus x e to the x, okay? So, the derivative of y is dy dx. Now, in order to take this derivative, this is x squared times e to the x, we have to do a product rule, right? So the product rule says take the derivative of x squared, that's 2x, keep the e to the x, plus keep the x squared times the derivative of e to the x is still e to the x. But guess what? This one also needs a product rule. So this has two product rules inside this problem. So here, we're going to take the derivative of negative x is negative 1, keep the second part, e to the x. Keep the first part, negative x, times the derivative of e to the x is e to the x. Okay, now let's see, can we combine like terms here? dy dx equals, I have, let's see, here's an x e to the x, and here's an x e to the x. So I have 1x e to the x plus an x squared e to the x minus e to the x. Now technically this is fine, but some of you might want to factor out a common e to the x, and that would leave us with an x squared plus x minus 1. Both of these are fine for me, okay? Okay, one last problem. F of x is sine x over e to the x. We want to find the derivative. This is going to need a quotient rule. So the quotient rule says take the derivative of the top, so the derivative of sine is cosine x, times, keep the bottom, e to the x, minus, keep the top, sine x, times the derivative of the bottom is e to the x, all over the bottom, e to the x squared. Now notice here we have a common e to the x, so I'm going to take out that e to the x, which will leave me with cosine x minus sine x all over, now e to the x squared is e to the 2x. This and this will simplify and leave me with an e to the x in the denominator, and just a cosine x minus sine x in the top, and this is f prime of x, which means our answer is choice B. There we go. All right, guys. Have a great night. Don't forget the chain rule. See you soon.